Our galaxy, the Milky Way, is teeming with planets. We have discovered thousands of exoplanets already. Many of them are similar in size and composition to Earth. Some even orbit within the habitable zones of their stars. These are regions where temperatures could allow for liquid water on their surfaces. The discovery of these exoplanets has ignited our imaginations. Could some of these distant worlds harbor life? The possibility is both exhilarating and daunting. The challenge lies in the vast distances that separate us. The closest star system, Alpha Centauri, is over 4 light-years away. That's trillions of miles. With our current technology, it would take tens of thousands of years to reach even the nearest star. This daunting reality makes interstellar travel seem like an impossible dream. How can we bridge these vast cosmic distances within human lifespans? The answer may lie in a concept once relegated to the realm of science fiction: the warp drive. Imagine traversing the cosmos, not by moving through space in the conventional sense, but by manipulating the very fabric of spacetime itself. This is the tantalizing promise of warp drive technology. It offers the potential to distort spacetime, creating a shortcut between 2 points and effectively circumventing the limitations of traditional propulsion systems. Though it may sound like pure fantasy, the concept of warp drive is rooted in theoretical physics and is being actively explored by scientists today. The pursuit of warp drive is not merely about satisfying our thirst for exploration. It represents a fundamental shift in our understanding of the universe and our place within it. If we can unlock the secrets of faster-than-light travel, we will not only open up the cosmos for exploration, but also redefine the boundaries of human ingenuity and usher in a new era of cosmic discovery. The idea of warp drive is most famously portrayed in the iconic science fiction series Star Trek. The Starship Enterprise, equipped with its powerful warp drive, captivated audiences with its ability to traverse vast distances across the galaxy. What was once confined to the imaginations of science fiction writers has become a subject of serious scientific inquiry. Physicists and engineers are now exploring the possibility of turning this once fictional concept into a reality. Warp drive technology, as envisioned by scientists, operates on the principle of manipulating spacetime. Instead of propelling a spacecraft through space at incredibly high speeds, a warp drive would create a bubble of warped spacetime around the craft. This bubble would contract spacetime in front of the spacecraft and expand it behind, effectively allowing the spacecraft to ride a wave of distorted spacetime. The beauty of this concept is that the spacecraft itself would remain stationary within the warp bubble. It wouldn't actually move faster than the speed of light within its local frame of reference. This clever workaround avoids the constraints imposed by Einstein's theory of relativity, which states that nothing can travel faster than light in a vacuum. The implications of such technology are profound. With warp drive, we could reach distant stars and galaxies within human lifespans, opening up a universe of possibilities for exploration, scientific discovery, and perhaps even the colonization of other planets. The development of warp drive would be a game-changer, transforming humanity from an earthbound species into a truly interstellar civilization. To grasp the concept of warp drive, we must delve into the realm of Einstein's theory of general relativity. This revolutionary theory, put forth in 1915, fundamentally altered our understanding of gravity. It posits that gravity is not a force acting at a distance, as Newton believed, but rather a curvature in the fabric of spacetime caused by the presence of mass and energy. Imagine a bowling ball placed on a trampoline. The ball creates a dip in the trampoline's surface, and if you roll a marble nearby, it will curve inward towards the bowling ball, drawn by the depression. This is a simple analogy for how gravity works according to general relativity. Massive objects like stars and planets warp the spacetime around them, influencing the motion of other objects, much like the bowling ball affects the marble on the trampoline. Now imagine creating a similar dip or warp in spacetime, but instead of a massive object, we use a hypothetical form of energy. This is the fundamental principle behind warp drive. By manipulating the curvature of spacetime, we could, in theory, create a warp bubble around a spacecraft. This bubble would compress spacetime in front of it and expand it behind, propelling the spacecraft forward like a surfer riding a wave. This manipulation of spacetime is not as far-fetched as it may seem. General relativity allows for the possibility of warping spacetime, and physicists have been exploring various theoretical frameworks to achieve this. However, significant challenges remain, including the need for exotic forms of matter and energy that we have yet to discover or create in substantial quantities. In 1994, Mexican theoretical physicist Miguel Alcubierre proposed a groundbreaking solution to Einstein's field equations that seemed to allow for faster-than-light travel. His solution, now known as the Alcubierre drive, provided the first mathematically sound framework for a warp drive. Alcubierre envisioned a spacecraft capable of compressing space-time in front of it while expanding it behind, creating a warp bubble that would allow for travel at speeds exceeding the speed of light. Alcubierre's model, while theoretically sound, came with a significant caveat. It required a peculiar ingredient called negative energy, or exotic matter. This hypothetical form of matter is theorized to possess negative mass energy density, effectively creating a repulsive gravitational effect. This negative energy would be essential for creating the warp bubble and achieving faster-than-light travel. The problem is that negative energy, while allowed by certain interpretations of quantum field theory, has never been observed in the quantities required for a warp drive. Some physicists even doubt its existence altogether. The creation and manipulation of negative energy, if even possible, remain formidable challenges. Despite these hurdles, Alcubierre's work ignited the imaginations of scientists and science fiction enthusiasts alike. His concept provided a glimmer of hope that faster-than-light travel, once relegated to the realm of fantasy, might one day become a reality. It paved the way for further research and inspired new generations of physicists to tackle the challenges of interstellar travel.